Hello, my name's Matt. I am from Digital and welcome to Coding for Climate Action Year 6, Lesson 3 walkthrough. And I'm pumped for this one. It's my favorite one from the whole unit of work. I love this this topic that we're going to get into. So let's get into it. So you know where to go, right? Digital.charity website is how you're going to get to the resources if you don't have them already. Resources. Coding for Climate Action, the whole link is up there. Fantastic. Let's scroll down. Year 6 climate careers is what we're looking at. We're going to need our climate careers skills, career skills chart open, and students are going to need their work journal open as well. So cool, that's there. Fantastic. Lesson 3 is a further exploration of some of the functionality of the microbit, right? So lesson 1, we introduced the unit context. We thought about the features of the microbit. We thought about some programming fundamentals. Lesson 2, we broaden out our understanding of those programming fundamentals and use them with different sensors, right? So we got students used to using the accelerometer, the shake, the move around, and then thought about how we can use temperature, light, and pins to input to as inputs to our microbit to trigger a warning system, right? So students are getting a variety of ways, and understanding a variety of ways that they can start triggering a warning system, okay, or triggering some sort of response from the microbit dependent on the environment. Cool. This session is going to introduce something called Create AI, which is just like the most awesome initiative from the Microbit Foundation. I love it. So it's a whole new way that we can use microbits in order to kind of, well, to respond to stuff around it. Okay. And Create AI is a machine learning tool, an AI tool that we can use with the microbit. Okay. So that's kind of the fundamental aspect of this lesson, is to carry on thinking about how we can respond to climate related situations, but now thinking about what AI movement related features we can use in the microbit to do that. So we're building up this repertoire, or students are building up a repertoire of skills. And the context of this is a landslide detection system. So we're going to create a landslide detection system. You might have gathered that from the title of the slide. So we'll start off the lesson by setting up this idea of what the accelerometer inputs are. So there's all of these different inputs that the microbit can recognize, okay? And therefore we can program based on, we can say, if we see, recognize or experience these like individual inputs, we could do something. I could say, you know, when logo up, play one noise, when logo down, play another noise, okay? So they're really cool. That's really good. It's a really awesome one of, if you ask me, one of the most fun aspects of the microbit itself. But there's like a limitation, which is that we can't use them in conjunction with one another. Okay, what if I want a mixture of inputs? What if I want a whole load of different inputs to result in something, not just one? So I don't want it to respond to being turned left or right or up or down. I want a whole sequence of events. For example, if it tilts left, then right, then shakes. Okay, how do I do that? Can it be done? Well, yes, it can, but it's really it's a bit complex. Okay, so here is some code that will do that. Students do not need to download this code or use this code. You certainly don't need to understand this code, but just to try and get across, and we can play about with it, but just to try and get across the idea that if we want to build in that level of bespoke, oh, some random shake things there. If we want to build in that level of kind of bespoke behavior, so we said tilt left, tilt right, and then shake, it's not going to work because I've forgot what it is. Yeah, tilts left, then right, then shakes. Let's have a look. Tilts left, tilts right, and then shakes. Probably not working because I'm moving it around while it's on there. But if we want that to actually be happening, we can see we need loads of variables. We need certain conditions in there, loads of different conditions. We need it to, you know, if we do it in the wrong order, we need it to overwrite it. It's really complicated. So it's actually better to teach the microbit, to train the microbit to recognize these instructions so it can just do it, rather than us like programming it in. Okay, and that's where Create AI comes in, which is a machine learning model. Okay, so this will mean we can yeah, use the Create AI tool, machine learning, to tell the microbit to recognize certain movements, certain behaviors, okay, so that when it experiences those again, it sort of has a certainty that, oh, well, you've told me that when I go in a circle like that, I should do, make this sound, and when I go up and down like this, I should make another sound, for example. Okay, we don't have to program it, we just teach it that those movements mean to do something. So kind of a quick discussion of what machine learning is. Okay, artificial intelligence where computers learn from data to identify patterns, and that's what we want our microbit to do. We want to identify patterns of movements without explicitly programming it. And machine learning is something that's used in the world all around us. So AI is often talked about, ChatGPT, generative AI, being this kind of game-changing, world-changing thing. But it's got loads of great aspects to it. But AI has been around for ages, and we all use it all the time, whether or not we know it. And we use machine learning in particular all the time in some of these kind of everyday tools that you see on the screen. All right, so we are going to use this to make a landslide detection system. The next few slides are talking through what landslides are, how they're related to climate change. Of course, we want to make sure that it's got like a relevant link to the world around us. So a video to watch and a work journal activity to complete. A bit more detail about what landslides are in the UK, the frequency of landslides, so we understand over these couple of slides that more extreme weather events, more rain, more intense rainfall could exacerbate an already existing factor of the UK that there are landslides. Okay, and then we'll think about how we can use our microbit to try and tackle that. So we're going to train our microbit to detect normal or low vibrations. So it's somewhere like near a railway track or something like that where we're worried there might be a landslide. Normal or low vibrations, that's just like cool, we don't have to worry about that. Minor movement, a little bit more movement, a significant vibration, a crazy movement like that, which simulates a landslide. Right, so in order to do this, and there is a video here, step-by-step video for how to create the program. So again, just like last lesson, I won't redo my work. Please just check out this video and watch the step-by-step tutorial, but I will just show you very quickly how to get to the website here. So microbit creates AI. Very simply click get started. I'm going to say new session because that's good. And we can see there's nothing happening at the moment on the screen at all because I haven't connected my microbit. So I want to click on connect and then follow the instructions. So I've got all of these things. I've got a microbit, yes. Computer, yes, yes, yes. Cool, I'm good to go. So we connect the cable. Hopefully this happens like in a timely fashion. Good, that's connected. Click next. Follow the instructions. It's going to download a program to the microbit, which allows the microbit to connect over Bluetooth to the web page and sends accelerometer data over to the web page. Okay, disconnected. Okie dokie. So we see I've disconnected it, and we've got a funny little shape on there. And you'll see next we get the same shape on the screen. So yeah, we know they're connected. We've got the same shape. So follow the pop-ups again. Always be clicking on the pop-ups. Click on pair. Connects via web Bluetooth, and if all is well, we have yay smiley face. And you can see hopefully as I move my microbit around, we can see the accelerometer data has stopped because I think my computer's grumpy. But the accelerometer data, there we go, that's back, is being transferred from the microbit to the web page where we can do our training. So I can do a quick thing here. So we can train and record our actions. So call it shake, click on record, and then I shake it and it teaches, says, well, that's an example of the microbit being shaken, so on and so forth. I won't do any more than that because all of the details are in the video for you to watch there. So please do scoot over to that video and check that out. That gives you a step-by-step of how to develop this particular landslide program for your for this lesson. Cool. So having been through that and made it, you'll see from the video you can draw through. In fact, if I just maybe very quickly do this, very quickly, I'm just gonna do some nonsense. There's my 3 shakes. Okay, having done that, oh, I need another one, do I? It's not letting me train my model yet. Okay, maybe I need another action still. So we need to also, yeah, train a micro when it's not moving. Okay, if it knows what one movement is, it needs to know when it's not moving as well. So I think this model is wanting multiple. There we go. Multiple kind of scenarios, moving and not moving. We can see now I've got enough data that it's ready to train. Okay, so we click on train model, start training, and what it's doing is it's analyzing the movement patterns, accelerometer data, so it knows a percentage certainty of which of these 2 different actions is being performed on the microbit. So it pulls us through, and if I shake the microbit, it says I'm 100% certain I'm shaking, and if I leave it still, it's a little bit in the middle. But I'm not surprised it's undecided, because if we go back and look at the edit data samples, I only got a couple, I didn't get much data here. Okay, so it probably wants more data to be more certain about that. There we go. Because maybe I held it at the same angle each time, right? So it's like, well, I want to be, there we go, that pulled back angle. You see how that's still, but I didn't hold it still at that angle or that angle, so it's not certain what that is. But once we're getting good, so you can go back and edit your data samples. Once we're getting good reports back on this, we can click on edit and make code, and it will pull through the code that we've developed here. And now I have got my make code environment with these machine learning on shake. So when I shake, I could have, for example, I could have, here's the music tab. I could choose some crazy noise. There we go. I don't think that's going to work with the microbit, but I can download this code now onto a microbit. Okay, so this microbit was used to train the data. I can now put this code onto any microbit and it will work, understanding whether it's shaking or still. Okay, hopefully that makes sense. So having utilized that kind of thinking, we've developed a landslide detection system. So thinking about the different warnings we could make, whether it's noise, whether it is we could have a flashing X in there as well. Let's pop that in. The clear screen and a pause, so it just doesn't happen like instantaneously and blow up brains. So there we go. So we could have our microbit, when it shakes, it makes a warning sound, and then we get a flashing X 4 times. Okay, so we're thinking about the different types of triggers we can have, the different types of warnings we can have. So yeah, please do work through that with students. And then we get some example solutions there. And I added a loop in. We could be encouraging students to be doing that as well. We could have some text scrolling across as well. Wrap up the lesson by thinking about what the benefits of machine learning are, how we used it to develop like a climate system, but also what the impacts are and any drawbacks to using machine learning. Okay, is it's thinking about maybe if we put bad data in, if we give bad training data, we get bad results. We saw that with my example, right? If I only held it in one certain direction, it thought it was still. If I held it still in another direction, it didn't think it was still. And then at the end of the lesson, of course, can we update our skills chart? So lesson 3, how did I do? I did a bit of programming, but like not lots. I did have to do, like engineering, probably, well, maybe more problem solving today. And then I'm going to say technology and design. In fact, 2 for technology and design and 1 for problem solving. That's what I'm giving myself. Okay, right. So programming and technology and design, those are my 2 areas I'm developing in. Hopefully that's been useful. Do check out the other video for a better explanation, a more detailed explanation of creating the actual landline, showing my age, the landslide detection system. See you on the next video. Thank you.